So welcome to Talking Language AI. This is a series where we talk about, we host talks and conversations about applied NLP topics, tools, and people. I'm Jay Alamar, and today I'm super excited to be speaking with Vincent Warmerdam. A quick bio. So Vincent has worked as an engineer, consultant, researcher, team lead, and an educator in the past. Currently, he works as a machine learning engineer over at Explosion, the company behind NLP tools like spaCy and Prodi.gy for data labeling. In addition to his work at Explosion, he also maintains many scikit-learn-related plugins, as well as popular learning resources at Calmcode.io, which is an incredible resource. If you've never seen Calmcode, you definitely check it out. We'll be hitting on it in this conversation today. Vincent is also a frequent speaker at conferences where he defends common sense over the hype in machine learning. So he's always sort of had these refreshing talks. And that was actually how I was first introduced to Vincent by seeing his talk in PyData, London, I think 2018. So welcome, Vincent. Thank you for joining us.
Yeah, happy to be here. Thanks for that introduction. But yeah, indeed. Yeah, it might have been 2019, but definitely PyData though. Yes.
How many of these have you done? So PyData, I think there's at least 2 or 3 of them on YouTube.
I mean, there's kind of a running gag with some old colleagues, like which PyData meetup have I not done in Europe, kind of at this point. But most of the conferences I've definitely done. I will say I'm a little bit different now. Like I used to be able to travel a lot. I have a kid now, so that, you know, makes traveling different. So I'm definitely sticking to the Dutch ones for now. But I've seen most of the European ones at this point.
Okay.
Yeah.
Amazing. So the format today is Vincent has prepared some materials to present, and we can jump in and have conversations about the various pieces he'll be presenting today. A lot of them are, or most of them, maybe all of them are tools that he's built. So Vincent has this skill of creating a lot of high quality things that are well documented, tools that are super practical. We'll be going over a few of them. If you have any questions, either live or when you watch this later on YouTube, the Discord link should be in the chat or in the description. Feel free to jump in, ask any questions, and we'll be sort of dealing with those and having those conversations. So I'd invite you to post any questions you have there. Otherwise, I'll hand it over to Vincent to start to show us what he's going to be sharing with us today.
Cool. So one AV check, we can see the shared screen, right? Just to quickly confirm so people can see the doodle, right? I got the nod. Good. Always good to double check that. But yeah, so today I'm going to be talking about just a bunch of tools that I've been working on that all have this theme of data quality. I didn't necessarily plan it, but that's kind of how we got here. There's going to be some live demos, but I kind of want to introduce the topic by sharing my favorite screenshot of a video game in the last year. So what I'm about to share actually happened. This is a screenshot in Flight Simulator. And what you can see here is like a flight simulator thing happening, kind of a flat background here. But in the middle over here, you see this sort of ominously, tower, kind of like Sauron's Tower of Mordor, and when you close up to it, you can clearly see this is obviously like suburbia. I believe it's Melbourne, but somehow the video game creators have managed to just put a giant skyscraper in here, except it wasn't a video game programmer that did this. So turns out that oops, full screen there. Flight Simulator is based on OpenStreetMaps. That was some of the metadata they used to create this world that you can fly in. And apparently there on OpenStreetMap, there is a user called Nathan Wright 120, and accidentally, by entering the wrong number in a form, he made this one house 212 stories big instead of just 2. With a result that now I think they've patched it up. But for a while, you could fly around in Flight Simulator and that'd be this ridiculous skyscraper that didn't exist. And the thing here, obviously, is like this is a funny story about a data quality issue. But there are moments when data quality issues arise and it's not this funny. This, by the way, is like one of the Today I Learns on my blog, but a common theme is I try to collect things that went wrong in terms of data quality. And turns out that there's the Udacity self-driving car data set, where you actually learn how to program a self-driving car. That is full of, oh, that was my cat. That's full of annotations missing for pedestrians. And, you know, imagine building a self-driving car where this woman and a stroller don't get detected. That'd be kind of bad. And similarly, like there's other things that go wrong too. Turns out that Sci-Far, one of the bigger data sets for image classification, they have very similar images, near duplicate images, and exact duplicate images between a train and test set. Like in the official train and test set, there's like absolute duplicates appearing. And then there's also, of course, like the bad label stuff. There's labelerrors.com. But a while ago, I also wrote this blog post on the Google Emotions data set. The idea there is there's a sentence from Reddit and multiple annotators try to attach emotions to it. And it turns out that, for example, thanks, nice input as always, is a sentence that's labeled as not about gratitude. Same thing with appreciate the time. Thank you, sir. Excellent work for this. This is why I love Reddit. You're amazing. Thank you so much. According to that data set, none of that is gratitude. And that's an issue because when you go to the documentation for that data set on Hugging Face, they will also give you this long list of models that were trained on that data. And some of those models have been downloaded 230,000 times. So I'm assuming that they actually get used somehow. And you kind of got to wonder, well, did all the model creators here actually look at the data and check the data quality? And what about all the people who are downloading this? Can they really just assume any data quality here or even any model quality? And here's where lots of trouble starts seeping in. We just don't know anymore. And that's a problem. And just to emphasize like the extent of the problem here, which is something not everyone appreciates. I mean, machine learning is done typically with this idea of you start with the data, you pre-process it, and then you push it through a model. And then you do some like grid search to get some metrics, like accuracy numbers. And if all that checks out, then you put it in production and you have these predictions. But we have this weird situation where the data can be crap, which can also mean that your predictions will be crap. Oh, but your metrics might still be shining at the same time. If we have Sci-Far 10 and there are examples in the train and test set, your accuracy numbers will look great. If there are bad labels, but you're able to predict them, your metrics will be great. So we are in this awkward scenario where I kind of have to fear this. We're all kind of taught that, you know, accuracy is good, but accuracy might no longer be enough if you actually start thinking about it. And this is kind of, with this realization, the ball kind of started rolling for me at least, that maybe there are some tools missing. And even if no one else uses it, I need to have tools available to me because this is stuff I actually start fearing a bit. So what I'm about to do in this talk is I'm about to show you just some tools that I've made in this theme. I've also written other tools, but there's a theme to all of this. And some of the tools will touch more on the modeling aspect. Some of the tools will touch more on the data aspect over here. But one overarching theme that I hope to convey is that all the tools that I'm making, they all have one central theme in common, and is that they're all tools that try to support this human in the loop. I really try to make tools that make it easy for me to have a look at all of these steps in the process and to maybe add some improvements. And it's really that human in the loop that I'm trying to drive home with some of these tools, even though they're very much ML based. So let's start then with the first tool. The first tool that I'll show you is something called Human Learn, which is a bit of a pun on scikit-learn. And that's a tool that tries to zoom in on this part of the pipeline. Like it tries to rethink the way that we model. And here's how it works. The idea is that it's a component that is very much scikit-learn compatible, but it has a slightly different vantage point. If you think about how machine learning works, like very, very broadly, then lately what we like to do is we like to take our labels as well as our data, And we give that to a machine learning model, which then tries to find all sorts of patterns that might fit the relationship between the labels and data. And, you just get some rules out, basically. Just get a sequence of patterns that get detected, and we can make some predictions. And this is very much different from how we used to do this. Back in the, I won't say good old days, but at least back in the old days, instead of resorting to machine learning, which is compute intensive, people would say, well, let's just spend a lot of time doing exploratory data analysis and maybe come up with some simple rules, which can then also make predictions for labels to us. And if you think about a few use cases like fraud analysis, let's say, I like to think that, yeah, you don't always need data in order to make a sensible prediction. And I thought this was just kind of interesting because maybe as in a scikit-learn ecosystem, we are overfitting on this and we are not doing enough of this. And then I started wondering, maybe there are these components that I can make that also make it easier to sort of exchange ideas between these two systems. And that's what human learn effectively is. It's just a bunch of scikit-learn components that you can just click in your pipeline that try to facilitate these kinds of models a bit more. Now, there's a ton of models in that package. I won't go over all of them, but I suppose the most powerful thing in there is this idea that you are usually doing maybe some exploratory data analysis when you're making predictions in the beginning, right? Like you have a data set, you kind of want to figure out what's in it. So then maybe use parallel coordinates to sort of figure out what's in there, some interactive visualization techniques. And the first, and I guess the main feature of this package is that by doing this exploratory work, you might be able to come up with a Python function that can just describe what your model should do. And then Human Learn offers this thing called a function classifier that can take any Python function and turn that into a scikit-learn component, basically. One that's compatible for grid search, which means that all these keyword arguments that you find in here are also something you can grid search over. And you might kind of go, okay, Vincent, but is that really, really powerful? Like, when would you actually use this? Is this something that's really state of the art? And the answer to that is not always, but let's do a quick demo where I'm going to convince you that this technique is actually more powerful than you might think. And for that, I have a notebook at the ready. Is the zoom good enough, Jay? Or maybe zoom in a bit more?
Yeah, I can see it well.
Okay, just zoom in one more just for good measure.
Even better.
Good. So this is Doubtlab. I'm assuming the crowd knows what this is. It's a neat interface. But what I got over here is a data set. And the data set in particular is the credit card data set. You might have heard of it. A lot of tutorials like to use it. Basically, these are all sorts of numeric features. We don't really know exactly what they mean, but we do know that they somehow resemble a transaction in a bank. You see all sorts of properties, I believe, that went through principal component analysis or something like that. And then we have this group variable that tries to say, was this fraudulent or not? That's the task of this data set.
So each row is a transaction?
Yes. It's a transaction and it got embedded somehow. We don't know how exactly, but it got embedded.
Okay.
So, and we know the amount of the transaction as well. So far, so good. But the reason why this data set is so often used in tutorials is because it's well known for being a imbalanced classification problem. Like there are way more non-fraudulent transactions than fraudulent transactions. So people consider that tricky. And there's tricks. You can do class weight stuff in scikit-learn. But
to elaborate on why that would be tricky, is it because if a model says everything is false, that would have very high accuracy and sort of seem good?
That's a start. So that's usually one of the issues. But there's also numerical things that might happen. So like there's also like very little signal to go on. It's also like another way of thinking about it. So if you say like, the loss from the positive cases, that's weighted way more. Well, if the loss is still tiny, you still got to maybe do a trick there. But the funny thing is you can go to Kaggle and lots of people write notebooks with algorithms to try to tackle this, but none of them try to do the visual trick. So let's do that. Something funny might happen. So here is the visual trick. I'm using a tool called HighPlot. And basically what you're looking at here is we have all the columns that we had before, and each transaction is now a line. So the way to think about this is that this was a transaction, and that one line resembles all the values that it had. So it had a certain value for V28, a certain value for V9. And this is, you can kind of see how everything just kind of connected. And this is kind of a neat way to visualize like 30 columns at a time. But what I could do is I can say, well, let's use that group that I had before to color. So now the color of the line is determined by the label I want to predict. And now when I just sort of look at this, you do kind of go, hang on, all the blue stuff, that's like the non-fraud. The orange stuff is the fraud. And it's pretty easy to just make a selection where all the lines are pretty orange. Okay, so those are easy to classify. Let's just remove those. HiPlot has a neat little trick that allows me to remove those. And then I can sort of make another selection. And if I squint my eyes, I see some more orange happening over here, but there's some blue lines as well. So let's maybe make like another selection. And by doing this, we are more critical, so to say. But again, it's pretty easy to just select a bunch of orange lines, right? It's not like something super fancy needs to happen here. So I can hit exclude again. And okay. What I did now, by the way, is on a train set. So I'm not peeking at a test set. This is like just making some selections on a train set. But if I just restore everything, I do hope it's relatively clear to you that I can just make a selection and turn this into an if-else statement, basically, right? It's a tree-based model that I don't need scikit-learn for. I can just write this down myself. And that's where human learn kind of comes around the corner, because you can just write that down as a function, basically. And I have some tools to make it very easy to make like a case-when tree, so to say. But yeah, then I have my function that can be turned into a function classifier. I can add keyword arguments here if I want to maybe fiddle around with some of these numbers that I've selected. But just doing this gives me a model with a 74 precision, a 73 recall, an F1 score of 73. It's not bad. Especially if you consider that there is this blog from this popular deep learning library called Keras that also uses this data set. And note, this blog post is well written. It's also written to explain Keras. It's not meant to be like the state of the art or anything. But if I just compare like the model that they use, that has a precision of like 24% and a recall of 80, which suggests to me at least that this is pretty competitive to deep learning. If only because I'm comparing to the Keras thing there, right? So this is not bad. And this is just domain knowledge. So on its own, I think this is a nice demo, but of course, this is usually not where the world ends. What I do recommend people do is maybe go a bit beyond this. Because what I think is the most interesting is when you have your rule-based system, which is something that you understand quite well as a human, and then you just compare that to a very deep learning system, random forest, big ensemble, whatever. And whenever these two systems disagree, you can just look at the data and try to figure out why. Because apparently something maybe got learned in the machine learning system that the rule-based system didn't capture. And if you can understand why, that might really help with fraud use cases. And that's something that's really easy to do because you just train a random forest on the same data. Performance is definitely better this time around because I am setting the class weight to balanced here, right? But yeah, you can find that there are like 120 examples or so where the random forest disagrees with our human learn component. Okay, there you go. Let's chase that, and you might learn something about fraud. And this is something I kind of like. You can come up with your own sort of little rule-based system, and by doing so, you might be able to find some bad labels, but you might also have a human in the loop that's also learning, so to say, because I do challenge you to come up with your own rules when using these sorts of tools.
So Vincent, if I can just stop for a second here. So
Yep.
I think three things that I'm taking away from this. So one is something like this can create a baseline, like a strong baseline that you can use to compare whatever model you train on next to compare it to. That is, let's say, one takeaway for me. The other one is that you can ensemble it and actually have it sort of be part of the final solution if it's. And the third one is that it's an exercise that forces you to look more at your data and understand a little bit of it. Does that capture sort of a?
Yeah, like I would add two things, I suppose, but you are totally right. Like one thing I might add is you can actually go to a domain person and basically ask them, how would you model this? Right? And then you can also come back to them and say, my machine learning model beat your thing, which if you're a consultant is very useful. Like it's great, great ammunition for a discussion. I guess like one thing I might want to add though, which is a thing that I really like to do with this. So like, let's say I have my X coming in, right? Then let's pretend that that data point that comes in is very much unlike anything the classifier has seen before. Like it's so far away from the bell curve, you can't even hear it ring. Like it's really, really out there. Then maybe it's a lot safer if I just have an outlier detection system here. And then the outlier detection system can say, well, you can fall back if an outlier is detected. Then I'm going to pass that to the classifier. And then also here, you can have like a fallback, but maybe a different one, because maybe the classifier has like zero confidence in any of the classes, so to say. Oh, and then, and only then are we going to make a actual prediction in production. Like if you want to implement this in a scikit-learn pipeline, it'd be nice if you can just implement it in a function. So it's also stuff like this that's just a little bit easier to implement if all you got to implement is just this one function. That's also part of what I'm hoping to achieve here. The people are just allowing themselves a little bit more creative freedom to figure out what a model can be.
Okay. And there's a question on just the robustness of the visual. Like if you shift the columns around, would that make, you know, some of the combinations or permutations more visible or not? Oh, you can pull them and drag them? Okay.
Yeah, so you could pull and drag them, but the comment is fair. I mean, so it is easier to see this orange bit if I move things around, right? So then there's definitely an obvious orange chunk here. You can fix this by just making this plot a couple of times with like random orders. That's like a thing you could do. I will say though, if it's just binary classification, there's usually it's very hard to find a order where all the orange is hidden. That's but also for regression use cases, I guess, like you can also say like, hey, I want to use the amount for coloring, for example. All sorts of sort of nifty things you can do. Maybe one thing that's also good to say about Highplot, the real use case for this isn't to do machine learning, it's to do grid search analysis. So like you have your giant grid of all of these different things that you've researched or tried, so to say. You just want to figure out which combinations of variables cause the best model. What you can then also do is like select a continuous variable and sort of select this way. It's more meant for grid search analysis than what I'm doing here. But Highplot is a cool tool. It also has a Streamlit package, but I usually use it from Jupyter.
Fascinating.
So yeah, hopefully that was a cool, interesting demo. I guess back to the slides. So I guess to the crowd watching, if you're curious about this, like whenever I demo this, a lot of people do kind of go like, hey, that's kind of a new way of modeling, kind of interesting. If you are curious about this, this is what Calmcode is for. I post some of these lessons here because no one else seems to be talking about them. If this is interesting, then in particular, I recommend checking out the Human Learn course, the Model Mining course, the Highplot course. And if you're doing anything with machine learning and you haven't seen Dion yet, check that out. It basically is a project that just generates sensible checklists of stuff you should do before even considering production. And for everything that is on the checklist, they also have a story of something that went wrong somewhere. Dion is an amazing project. Check that out if you haven't already. Courses on Calmcode. Everything's free. So I guess I can move on to the next tool, right? Because we can do questions after, I suppose.
Yes, I think we addressed some of the questions.
We can also do questions now, just a matter of preference.
Okay. I think a couple of things that will clarify a little bit of what's to come next. So one, when you say human in the loop, the human you have in mind is a data scientist. Is that
yep.
the profile you think?
Yeah, but I mean, the data scientist should also reach out to the domain expert, right? I mean, that's also a human. But I want to have more humans and less black boxes. That's the idea. And sometimes it's fine to use a neural network, but I still like to be able to peek in to help, like figure out how to debug it. Like that's the thing I want to try and do more of.
And there's just a quick question from the Discord on the idea that if you can just break it down a little bit more, why it's a problem if the same example is in both the test set and, or something very similar to it is in the training set.
Yeah, so like imagine, for example, that oh, what's a fun one? Let's say I'm building a chatbot, let's say. And I kind of want to know if the chatbot's any good. Well, then I kind of need a way to judge the chatbot, but it's kind of cheating if I'm giving it all these examples of, hey, if a user says this, it's probably hello. If a user says that, it's probably goodbye. Like you're trying to predict intent, so to say. Like one thing the machine learning model can end up doing is they can end up memorizing the specific text, which is literally like an if statement. If this text, then this is the intent. And you want models to generalize. Okay, so if we want models to generalize, we need some sort of measure. So then people come up with accuracy numbers, so to say, which is a reasonable idea. But then if you're judging the model on the same data set that you're training it on, you are at risk of reporting memorization, which is not what you want. That's my gut feeling, at least. I will mention, like, metrics aren't everything. They're not necessarily enough, but they are like a proxy, if nothing else, that can be useful. But the moment you use the test set as your train set and vice versa, it just becomes a way less useful number to track.
Awesome. And then a couple of questions on using human learn for regression tasks or the visualization for like embeddings.
So there are some experimental visualization tools. I'm having a bit of trouble maintaining those because Bokeh and Jupyter don't always share the right port number. So those are in the experimental features. That said, I have a function classifier, but I also have a function regressor. So if you have a regression task, you can also just write a function. If you have an outlier task, you can also just write a function. And if you have a data transformation task, you can also go ahead and totally do that. Those are all tools that are inside of human learn. The visualization stuff is a bit more on the experimental side. That's mainly because the IPy widgets ecosystem changes from time to time, and it's kind of hard to keep track of that. But the core of it are these function classifiers and the like. So those are all very stable and well tested.
Amazing. Yeah, we can take it away to the next section.
Cool. So, okay. What I just showed you was a trick that you can use inside of the modeling space. And this is not at all the only trick at all. But I do hope that we can also appreciate that if you fix stuff at this phase, it might already be too late. Because if all sorts of tomfoolery is happening with your data, you know, even if you have a great model, your metrics can still be off because your data is off. So just fixing your model might not be enough. Ines, who works at Explosion, who also has a little bit of internet fame, once coined the term, we don't just want to iterate on our model, we also want to iterate on our data. Before people started calling it data-centric AI, I always used to prefer that phrasing. So maybe what I should also work on is tools that don't just iterate on the model. I should also work on tools that iterate on the data. And if I think about the main issue, and then I'm thinking about bad labels. That's like a thing that's just too common, I think, especially in the academic data sets that people like to use to benchmark models. So, okay, what can I do to maybe find bad labels in my data set? Well, to keep things simple, I'll just assume text classification, but everything I'm about to say works for any classification in general. So I have text and a label, but it can also just be anything tabular or anything computer vision, what have you. Well, then, even if there are errors in my data set, one thing I can always do is just train a bunch of models on it. And I can also train two models. Let's say one that's a little bit more bag of wordsy, another one that's a bit more bird-like. Well, then maybe I can then come up with some signals that might tell me that something is off in at least a row or something, given that I have a data set and some models. And note that I am assuming that all of these models are somewhat accurate. These are not models with like zero accuracy or anything like that. Okay, so here's a list. If I have a model and it's really uncertain about all the classes, like there's two classes and both are predicted with 0.5%, so to say, something weird might be happening. It's just it might be an outlier, but it's some sort of example where the model just doesn't really know what to do. That might be because the label is just off. It might deserve checking. Another thing that can happen is you can be high on confidence for the wrong class, which is something you don't want. And you can also be low on confidence for the correct one. In the case of binary classification, these two things point to the same thing, but if you have, let's say, 8 classes, then these two are not necessarily the same, but both could imply that something weird is happening. You can also have two models that just disagree. That's also always interesting. It might also be the case that you're just detecting an outlier, which can happen in all sorts of different ways. And it can also be the case that, let's say you have 5 classes and there's just a whole lot of confusion in the top 2. It could be like a confusion matrix thing, but again, there might also be something happening with the label. And the way that I like to think about this is none of these sort of reasons are a reason to fully say, oh, the label's bad, but they all are reasons to doubt. That's kind of the gimmick here. So Doubtlab is just a suite of tools that allows you to doubt your data just a bit more. And it can also help you prioritize which examples to check first. And the basic rule is the more of these reasons overlap, the higher the confidence that something weird is happening. That's the whole pitch. This is what Doubtlab does. And it's just sort of a big box of Legos with tools to help you do this. But I am completely free to whatever model you like. As long as it follows the scikit-learn API, you can use whatever you want. And this is the entire API. The API is relatively simple. I have this one object called a doubt ensemble. The doubt ensemble wants to have a dictionary that has a name followed by a reason. A reason is something that we provide. You can have a probability reason, which is basically saying, hey, the maximum probability value that comes out of the model is just kind of low. Could be a reason. Another reason is that you made a wrong prediction. Can also be a reason. Here's the definition of the reasons. I put that in my doubt ensemble, and then I have an object that can prioritize examples for me. The way that you would use this is you would give it your doubt ensemble your X and your Y values, so to say. You can totally do this on your train set as well. And then you can generate a data frame with what I call predicates, which is basically just saying, hey, this reason was fired on row 77. This reason was also triggered on row 77. Hey, both got triggered. This is a sorted table. This needs to be checked first. And this sorting is basically just, hey, how many of these things got triggered? And that's about it. But because you are able to use whatever model you like, and because there's just lots of these reasons to pick from, you can have 10 reasons, and when they overlap, odds are it's worth double checking. I've used this on a bunch of data sets, and it seems to work quite well, even if you're just using some simple tricks. So here I'm using the Google Emotions data set once again, and I'm trying to figure out, hey, what are some bad labels for the excitement emotion? Here I'm using a bag of words model with logistic regression, and I'm just checking, hey, when do we have confidence for the wrong class? So apparently the sentence, I'm inexplicably excited by name. I get so excited by how he curl passes, which is a sentence that has the word excited twice. That's not about excitement, according to the label. Oh my God, this is amazing. Keep up the awesome work and have a fantastic new year. I mean, we can debate whether or not this should or should not be excitement, but I do agree that these are like examples that deserve a little bit of doubt, at least. But here's the cool thing. This is bag of words logistic regression, but nothing is stopping me from creating whatever other model I like. So I can also use a pooling of subword vectors and pass that to a logistic regression. And when I do that, I get different examples. In particular, I get examples that are short. And that makes a little bit of sense if you think about it. If you have all sorts of subword embeddings, right? Let's say byte pair embeddings. If I pool them all together by averaging them or by adding them together, I do lose some information the more stuff I just keep adding. So it makes sense that a lot of long sentences don't have as much information anymore because you just get this averaged random set at some point. Or like something very close to zero, something very flat. So it makes sense that like the subword embedding model is very pronounced in short sentences. And that's interesting because the opposite might be happening to logistic regression. Because all of those, the cat is also joining. Bye. Because if you think about how logistic regression works, every token, every word that's in the bag contributes more weight. So if there are lots of words in it, then the opportunity for lots of weight to be attached to a prediction is also there. And that might also be why all the wrong classifications happen for longer sentences here. But this is super cool. You can just be diverse here, which I think is also super interesting. You can be diverse in the reasons that you pick, but you can also be diverse in the models that you pick. And while all of this is happening, it's not like I'm doing rocket science either. These are just some simple heuristics, really, of stuff that should generally work quite well. So that brings me to the workflow. Like, how are you supposed to use this tool? Well, typically, I like to think there's this big data set that comes pre-labeled. And what you're really just trying to do is using Doubtlab to create this subset to check. It's probably not the best idea to go through every single example in the big data set because time is limited, but it can be a reasonable idea to say, well, let's just look at the small data sets where most of the reasons just get fired off. And what I really like to do then is just give that small little subset to a human with a annotation tool. Call me biased, but my favorite one is Prodi.gy. And then what I would like to do is, given that I have some subset that I checked and where some bad examples got removed, then I can combine the big data set, remove the bad examples from it, maybe replace them with cleaned examples. And then I do like to think that I have a model that's just a little bit more reliable. I don't want to suggest that this is perfect or enough, right? Because lots of other stuff can go wrong too. But I like the idea of doing this exercise. Like once every month, or at least every year or so, it makes sense to just check if some bad labels have seeped into our production system. Note, if you're interested in this, by the way, it's part of my job these days to once in a while make a tutorial on how to do this. So there are these Prodi.gy tutorial videos where, yes, I use Prodi.gy, but I usually try to show off a cool trick. All the tricks that I've shown you so far are Doubtlab are in this video. There's also a trick that's not really compatible to the API that uses UMAP. But if you're doing image stuff, you might also like to watch this video. That's a bad label detection trick that uses UMAP. It doesn't work with Doubtlab, but it's also a useful trick to at least try. Now, before questions are being asked about this, I do want to give like a quick shout out. If Doubtlab seems interesting to you and you want to make contributions, like there is this balance between offering every single trick in the book out there and saying, well, let's just be pragmatic. 9 times out of 10, these tricks are sufficient. But I do think that there's this one thing that people can do to really help me out. And that is that I am very much in the market for more examples. I have a pretty nice tutorial on how to do this for Google Emotions on that data set. But I would love to just have more examples on this page, basically, such that we can also maybe share some more tricks on like stuff that went wrong in other data sets as well. So you don't even have to write code for this. You can also just supply me with a notebook with an interesting research result. And if that sounds like an easier contribution to make, reach out to me on GitHub. I'm definitely in the market for more examples on the docs here. And I also think this can be a fun exercise in general. It's always nice to see something fixed and like bad data is definitely like a, if you haven't dived into the project already as a data scientist, I highly recommend people start exploring the field because there's lots of lessons to learn, basically. So no demo for this, but I think, I hope at least people got the gist of it.
Yeah, that's a great overview. So for the call for contributions, it's for data sets that are classification labeled data sets for like supervised learning. Do they have to be text or other? What
no, doesn't have to be. I'm also gonna show you a tool in a bit that's gonna help you with this. But there's also regressor tricks in here as well. So also for regression, there's a couple of heuristics like, hey, the absolute difference between what I'm predicting and what I'm seeing is different. Stuff you can do there as well. I'm mainly interested in kind of the blog post. So I will help you with this, obviously. Like if you have a cool direction, you don't have to do the whole thing. But I just want to have more examples of, it's not just Google Emotions that has issues. A bunch of data sets do. And I'm hoping that this can be a source of inspiration to people. Because the tools are there. It's just that I like to think this needs to be a practice that more people need to do.
Okay. And is there a notebook for your examination of Google Emotions? I know there's a blog post, but like the exact code.
Yep. No. So the blog post has the code basically.
Okay.
And if there's anything missing, add an issue to GitHub, and I'll gladly check it. Note Calmcode also has a bad labels course, by the way. If people are interested in that. But also these videos from Explosion, they also come with notebooks that are also hosted by us. So people can also find the stuff there.
Awesome. Yeah, it's always fascinating to re-examine labels that models misclassify, or it's always tells you something, I think, profound, like when you go through it, that has you sort of think about it again and again.
There's also a website called labelerrors.com, which is a cool website to visit because it takes all these big academic data sets and it shows you like all the bad labels that have supposedly been found by like tricks. They also come with some research. I think it's estimated that like the Amazon sentiment corpus has like a 2% label error. I recall Quick Draw had a 10% label error. Like, if you're interested in this, I also highly recommend you check this website, by the way, because the label errors are out there.
Okay. There's a question on if you have citations for these tools, if people want to cite them in papers. I know some of your blog posts have, but the tools themselves.
Yeah, if people have questions on this, typically what I got to do. So Human Learn has a scikit-lego and Human Learn have a DOJ, I think. It's like you can put it on a website somewhere and then it's citable. I just need to do it for all of my packages and I haven't done that yet. If people want to use this tool in their research, they're more than welcome to. And if they have trouble citing, just raise an issue and I'll help you figure that out.
Okay.
Cool. Awesome. So I guess like one thing I do maybe want to mention before moving on, this whole idea of bad labels, it also helps to take a step back. In general, if there are bad labels, it's not necessarily the fault of the annotator. It is typically also the fault of like the annotation process. And one thing in Google Emotions in particular that I do think is good to share is that it has been labeled by people around the globe, also the other side of the planet. And you can wonder if, let's say, an English speaker in India that's 50 understands internet slang the same way that a 20-year-old does in California. So it's be careful with assigning blame whenever you're talking about bad labels. And also, Doubtlab will not fix the annotation process for you. It will, however, hopefully help you discover the presence of some bad labels, which can then be motivation for the next step. But pointing out bad labels is not the same thing as fixing them. Like, that's definitely like another step, something we're not fixing here. Oh, okay, cool. Let's talk about more tools. But in order to do that, I'm going to take a small jump because I'm about to show a tool that doesn't really put the human in the loop directly. But hopefully by the end, it becomes obvious that it is something we will need to do even more cool tricks in this department. And that has to do with embeddings. So embeddings exist for all sorts of things these days. It's not just word embeddings. We've got language models. We've got universal sentence encoders, subword embeddings, multi-word embeddings, sense-to-vec, image stuff, audio stuff. And embeddings can be super powerful. But the one thing I've started disliking about them is that I am a kind of person who really likes to iterate quickly, and I'm not the kind of person who likes to learn a new framework just in order to use an embedding. So there's Keras and TensorFlow and PyTorch and JAX nowadays, and I'm sure cool stuff's happening in them. But if I just want to quickly try out, hey, how is this multilingual embedding? Is that useful for Dutch? I don't want to learn PyTorch. Like, that's a step that's blocking me from just trying something out real quick. So I just want these embeddings to be just a little bit better for my use case, which is how I came to the name Embetter. The way it works, really, is it just turns a lot of the, what I think are reasonably useful embeddings out there into scikit-learn components. So here's a code snippet. From Embetter, I'm grabbing two components. There is a column grabber that allows you to select a single column from a pandas data frame. That's kind of useful when you're working with text because sentence encoders typically don't speak pandas. They speak lists of text. But this still allows you to make a scikit-learn pipeline where first you're grabbing the text. In this case, then you're grabbing the sentence encoder, and then you're using UMAP. So you can go from a CSV to a Python list to a embedding array to a two-dimensional embedding array. And oh my God, it's just one line of code. I like this. Like, that's kind of the vibe that I'm going for here. It's not necessarily meant to be state of the art because we're not directly fine-tuning anything with this, But just as a featureizer, it's one line of code. That's what Embetter is trying to do. And it doesn't just do this for text, by the way. Why stop there? Because what I can also do is something very similar, but instead of grabbing text, I'm grabbing a column called path, which has a path to an image. This will then grab me a list of strings referring to file paths. Then I can use an image loader, which turns that into a Python image library object, which is an object that Keras usually likes, as well as the PyTorch image library. Tim, by the way. And this Tim encoder can then grab very popular pre-trained image classification models like exception. And you're able to use either the final layer or the layer before. That's also like a hyperparameter you can select here. And again, you can UMap afterwards, but this is something you can also totally do. Images can also just be encoded. And images are also supported right now. So I don't do audio just yet, but text and images are definitely supported. I use the sentence encoders library for text mainly. That seems to be the most stable thing out there and quite reasonable. For substrings, I use sense2vec, and for images, the Tim library really made it very easy for me, so I can highly recommend that. But that's what Embetter does. It just gives you these Lego bricks for these embeddings. And I'm not going to implement all of them, but my goal is to implement a bunch of them that are reasonable to just use for quick iteration. So you might think, okay, you've got these vectors, but now what? And just as a demo, what I would like to do now is just show you how cool it is to have these Lego bricks around, because you can do some fun stuff. And note that I'm not necessarily doing state-of-the-art stuff. I just want to emphasize how fun it is to build stuff with these tools. Because it's also a one-liner to do few-shot classification now with this. So let's zoom in a bit again. We are back. So again, I have my cell of code over here, and again, I have Embetter and I have a sentence encoder here. Note that when you install this tool, you probably do want to pip install Embetter with all the tools that you need. So if you want to have text tools around, you do need to add this little text flag. Otherwise, these are pretty big models. I don't want to download everything, but this is a step that I ran up front. But this gives me a pipeline that can grab a column from a pandas data frame and then encode it. So if I have a data frame like this, where I have text, this is amazing, I totally hate this, and I am very neutral, with like a label that I just came up with, then this pipeline can just go ahead and take that, and it's going to encode the text in this column. Here's the pipeline that I run. We can see that we get 3 rows and 384 dimensions. That's what the what this all mini LM model outputs basically. And
just to clarify this model, can you use any Hugging Face like model name and that would sort of retrieve it, or is it specifically like a hard link to this model for now?
So if you go to sbert.net, I'm using the sentence encoder one. I think they support a lot of Hugging Face, but I don't know for sure if it supports all. What I will say is the main thing that I liked about it, if you go to the website, you get this interface where you can kind of pick, I want to have a more lightweight model and a more heavy model. Yeah. And also these are all sentence encoders. So like that phenomenon where we just add all the word embeddings together, pool it, and lose information. That doesn't happen here because these are all kind of BERT models.
Or sentence embedding models specifically, yes.
Yeah, so BERT-like, and there's different architectures, of course. But also there's some multilingual stuff in there. LaBase is supported, which I remember using at Rasa a bunch, which I liked. It's mainly because it's simple and pragmatic, which is good enough. It's kind of the attitude here.
It's a really good API. Yes, Sentence Transformers is an incredible tool.
It's a well-written library. It even has like vision stuff in it for like search. But for our purposes now, though, we can also do something cool. So what I can do is I can basically make the same pipeline, but I just add a kneighbors classifier with one neighbor. What will that do? Well, okay, I'm going to draw it in 3 dimensions, right? And obviously, this is not happening in 3 dimensions. This is happening in like 384 dimensions, but let's pretend it's 3. I have this one embedding to which I attached the positive label. I had this other one, which had the negative one, And somewhere, maybe over here, I have the neutral one. So let's now pick a different color. Let's now pretend that a new sentence comes in. Well, it will get embedded, and it will end up somewhere, maybe over here. So that's the new word. And then what can I do? Well, it's a bit of a gamble. What you could do, it's not guaranteed to be perfect. What you could do is you could say, well, let's look at the distance from like the original examples that I had and this new guy. And whatever distance is shortest, just attach that label. And it kind of falls in the realm of like few shot learning because I'm really just giving it one example and I'm saying, as long as it's similar, go for it. But it kind of works. That's the funny thing about it. It depends a bit on like, hey, are the embeddings trained on data that resemble the data that I'm seeing over here? But what I really like is you don't necessarily need to pick a zero-shot library or anything like that. The only thing you need is like this embedding and whatever favorite scikit-learn component you like. This is a much more flexible box of Legos than a zero-shot library. And also note that you don't have to think about tokenization at all. That's also handled by the sentence encoder for you. And just as a quick demo, this just works. So that's just wonderful, positive. Oh no, this is bad, negative. I don't really care much, neutral. And you can like maybe make it like 10 neighbors and maybe add like a little bit more training data than what we just gave it. But this is no effort at all. And that's kind of the point. And if you wanted to do something more fancy, like one thing you can also do, by the way, because it's scikit-learn, you can also say, well, let's just make the pipeline, but then split such that for the text, we are doing like bags of words as well as features together with the sentence encoder. And this way, if I attach a logistic regression at the end, it'll split and it'll come back together again. But then this logistic regression has access to the sentence encoder and bags of word features, which is great if you're trying to fine tune it towards a domain that has rare words that aren't necessarily found in common data sets.
So the feature vector would be, let's say, a concatenation of both the sentence embedding and then the whatever bag of words. Vector.
Totally. And you can also do like, if you're worried about training times, sometimes you can speed things up by doing more tricks. Like you can follow the count factorizer up with like SVD or whatever. But that's the cool thing about scikit-learn. Scikit-learn doesn't care. You just, here's a box of Legos and just play with it. And just that freedom, I think, is like very liberating and cool. Also, like if you're into this sort of thing, the sentence encoder also adheres to the partial fit API. So you can also do online learning if you want. So if you have a larger than memory data set, you can still use it. It also means that for active learning purposes, you can also just train on a few examples that get annotated. That's also something you could totally do. But now, you might think, okay, Embetter is kind of cool. We can do some cool tricks with it. But hopefully now it's also kind of cool why Embetter matters, because it's not just for wrapper prototype and for classification where this is interesting. I can also use it for labeling. But before we go into that, maybe it's a good time to get questions answered, because I'm about to jump to the fourth tool.
All right. So yeah, we had addressed a few of them already on merging, on Hugging Face. Yeah, I think we can move on.
There's one feature that I haven't done yet, and that's the GPU support. So I do acknowledge that like some of these tools, especially if you're using Google Colab, they can get heavy. So adding GPU support will be nice. It's in the back of my mind on the roadmap. It's not done yet though, but I can imagine like if you have a very huge data set, just getting these features can become the bottleneck. So if you add GPU support just for that, we might be able to speed some things up. On the roadmap, haven't gotten to it yet. Okay, so why does Embetter matter is now something that I hear people think virtually. Because we were talking about data quality, like why do I care so much about these embeddings? And that's in a different scenario than what I discussed before. Like in Doubtlab, I assumed, hey, let's pretend that we have a label data set, but let's now think about the inception of a machine learning pipeline where maybe all the data we have is unlabeled. Then we want to get from this unlabeled data set to some sort of a trained model. And then it's very likely that in the middle, you are going to use an annotation tool, but you would like to use an annotation tool in a very effective way. Because again, this can be a super large data set, and maybe not everything in this data set is going to be relevant to this trained model. Maybe I'm interested in 3 classes, but this large data set has like 20 of them, only a subset of which are of interest to me. We can kind of do something similar. We can use quote unquote some trick to create a subset of interest. And some trick is very easy if you have embeddings around. For example, with that 0 shots stuff that I just kind of demoed, let's say that I have just 4 examples of each class that I'm interested in. And let's also say that I just make this one other class called other. Then I do have, with very few training data, just a trick that is able to give me a subset where, sure, there are some mistakes in there, but those are mistakes that, those are examples that are probably very similar to the text that I want to distinguish. So those would be good examples to annotate, actually. And especially if you're getting started and only have an hour, yeah, like you can actually apply some trick with Embetter very quickly if you think about it. But okay, what might be the coolest thing that we can do with this Embetter thing? And then we kind of combine it with the human learn way of thinking. Like maybe we can do something visual. Because there's some other stuff that we can do. Like let's say I'm doing something with like approximate nearest neighbors. I have some sort of vector database. I encode everything in here. What I can also just do is say, here's a sentence, find me all the stuff that's similar. Sure. Also, cool trick. Probably will work. We can also do that. But can we do something where the human is just in the loop a little bit more? Now, one thing I do want to maybe mention about Prodi.gy that's kind of sweet is Prodi.gy is a programmatic tool. So I'm actually able to make an annotation interface that is generated by something that I wrote in Python. And maybe there's like an extra trick there that's worth mentioning. That's related to like the labeling interface. Like if I think about how can I speed things up? I mean, one trick that we can do is we can say, let's make a subset of interest. But anything that we can do that just makes our life as a human better inside of Prodi.gy, that would also be kind of sweet. So imagine that, I have this interface that kind of looks like this. I have a sentence over here, and I got to say, well, which of these classes apply? And then I can hit this button to confirm. Like green means yes, red means no, and I can also sort of skip. I mean, it's not a huge cognitive load, right? But you do have to think, like, which of these labels actually is it? And imagine now that instead you were to say, well, the model thinks it's this one. Is that right? Yes or no? And imagine now that we are also constraining ourselves to just one class, just to keep things simple. Then as you're sitting there and as you're annotating, it becomes a very quick yes-no thing compared to the, oh, which one of these is it? And we shouldn't underestimate just what kind of a big difference, also in terms of label quality, it can mean to be able to make this UI step. So that's also kind of cool about these sorts of embedding tricks, right? But then what can we do to make sure that we get like a nice little topic with unlabeled data? So here's the trick that I had in mind when I was building Embetter. I built this for this particular use case, and then some other use cases came about. But I had bulk in mind, and then I made Embetter, not the other way around. So here's what you can do. Again, we're going to embed stuff. So grab your text, embed it. Okay, vector, great. Next up, what you can do is you can UMap it. UMap is a dimensionality reduction technique, just like PCA is a reduction technique. The one difference is that PCA tries to keep the global structure intact, and UMap basically says, nah, global structure can go away, but I do want the local clusters to still make sense. So how the clusters relate to each other makes no sense in a UMap chart, but within a cluster, you do get stuff that should be relatively similar. Now, when you do that, then you can sort of take your original CSV file and just attach 2 columns to it, X and Y. And that will allow you to make a 2-dimensional chart. And if everything goes well, if the texts here have clusters in them, and if the embeddings are able to translate that into something that UMap can reduce to, they get this 2-dimensional chart where maybe we can just make a selection, and then stuff within that selection is the same topic. And maybe when I do that, I can say, well, just take this subset of stuff that should be the same topic, and let's just give that to Prodi.gy. And that's what bulk does. Bulk is this like the most minimum viable product I could come up with that does just this one thing. It's a command line tool. You can type bulk text and then a CSV file. And if it has a text column, an X column, and a Y column, it is able to generate this. And I would like to give a quick demo of just that. There we go. Now I am running this over SSH, so I do hope the demo deities are with me on this one. What I have here is just this one data set that I prepared up front. Bulk text, there we go. A window popped open here, great. And we'll move that to this screen. And there we go. This is bulk. Now the way it works is I can make a quick selection. I can use the lasso tool to make a selection. And whenever I do that, you'll notice that some of the points here light up, and all the text examples that belong to that example are shown here. So this allows me to very quickly try and get an overview. In this particular case, when I make this selection, Xmas, Christmas, 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 Christmas. So this seems to be the Christmas cluster. This seems to be the Call of Duty cluster. That's also something that apparently you could buy in the store. And there's a cluster over here, if I remember correctly. It's all about the website that went down. It's also kind of a cluster that you have here. And what I could go ahead and do is I could just say, hey, the website.csv, save it. And then if I were to go back, then the website.csv just appeared. So this is a very convenient way for me to just make that subset that I can just pass into Prodi.gy. And again, this definitely won't be perfect, but it's quick. And it's also like a, I know you did topic modeling last week, but I also kind of like to see this tool as like a topic discovery kind of a thing, where you just kind of look at this, you kind of go, well, I wonder what this is. And you can kind of explore it. To make this just a bit easier, though, there is this like one extra feature that I did add. Let's close this browser and go back here. So one thing you can also do is you can add color. So you can say, hey, same command line stuff, but keywords, please give a color to these words if they appear in the sentence. And when I do that, the same interface appears as before, but now you can also see some clusters, sort of because the color is there. So apparently, the word delivery happens all over the place here. And this is making me realize that maybe it wasn't so much about Christmas, but about the Christmas delivery. And like another thing that's interesting here is a lot of this stuff seems to be about delivery, but if I look for the word order, which is like a synonym, then I can also see that appear here. So it's not necessarily the same as token matching. It's actually using the embeddings. And again, like this is kind of a minimal thing, but this has made me quite productive, I will say. And it's because I'm able to build on top of these embeddings quite quickly that it's just kind of a joy to use. Also, because I, as a human, am learning while doing this. I don't recommend anyone doing this to also think that the labels are going to be perfect. They won't be. But it is just a little bit more fun to label this way because I'm also learning while I'm annotating. So I hope that was cool. I have one really cool demo that's a little bit about the future of what the stack can do, which we can do questions now, or we can do them after this final little demo, which might be fun.
Just a quick question. So
yeah.
You showed the visualization of the UMAP sort of, and that seems to be, one of the strongest ways or intuitive ways for people to visualize documents, where it's a scatter plot and each point is a document. In the discussion on topic modeling in the last episode, Martin showed us that, a number of visualizations in per topic, and that one in particular is probably the most important one. I find it as well the most informative in topic modeling and, let's say, explorations of text archives. What I love that you're doing here is that you're taking it from more of just, this is a visual, this is a way for you to explore it, but you're making it a little bit more interactive in terms of, I can do something about it. I can extract this region of text. I can have that. What would be the next step usually after you export a CSV of a cluster that you've sort of identified?
I mean, so the intent is that this is used in the beginning of the project. So I can imagine that, let's say you use this to have your first 100 labels per class, let's say. I think this can be quite reasonable. This approach can be quite reasonable for that, especially with the colors. At some point, though, you can also wonder, well, what happens if I train a machine learning model on that data? Because, my data might be domain specific. So I might need like a custom model that's like very bespoke to that data set that I have. And then maybe that bespoke model is maybe just a bit better at some point than the original embeddings that I started with, which are usually a bit more general. And then maybe active learning with that model makes more sense. So bulk, in my mind, is definitely more something I would use like in the beginning of a project, not something I would use throughout. Because it's really a quick getting started. That's kind of the gist.
And it's for use cases where somebody wants to build a classifier or some sort of model. They don't have enough labeled data. This is a way to generate a lot of data very quickly, visually, and sort of interactively like this.
Yes, although I do want to stress, I do recommend, like, I have heard stories of people saying, oh, I'm not going to even throw it in Prodi.gy afterwards. I'm just going to train on this. Do that at your own risk, because again, these embeddings are not going to be perfect. You are going to get some bad labels in there. You can use Doubtlab to find them, but the more appropriate way of going about that then is to just annotate the data yourself as well.
Okay.
Like I do believe in that, mainly also because you are then confronted with how messy the data might be, right? And you might also ask the question, why on earth did the embedding model think that this was about deliveries? Like, that's also a very, very good question to sort of have in your face. Again, which is why I really recommend people annotate their own data themselves.
Okay. And then you built bulk. It runs on a, let's say, I think a Python server. Is there a reason why this wouldn't have been done with like Streamlit or Radio or one of these Python sort of, or is it too simple to require that overhead?
So the truth, I mean, the only tool that I found that really had this lasso component work well is Bokeh. It's just the one visualization library that did that in a scalable way, in the way that I liked. The earlier version of this is called ClueStar, which does this with Altair, but they don't allow you to make a selection and then have available in Python land. So that's the main reason. There is also a reason, like people have asked me, like, why doesn't this work in a notebook? Which I think is a fair question. I kind of like the fact that this is without distraction, if I'm honest there. So that's why I don't feel like I have to implement for the notebook as well. Like, I'm also a bit selfish here because I'm of the opinion that this works. I can defend the way it works, and it works for me. Feel free to fork it. Like if you really feel strongly it should be differently, because I think this is actually not a bad way to do it. By design, it's also meant to have like as few distractions as possible, which is also why you just give it a file name and you hit save. That's about it, just to keep things simple.
Amazing.
Now, having said that, there's like a kind of a cool trick that you can do in Embetter soon. Not yet, but soon. Because bulk also does images, right? Because Embetter does images. So the only thing I had to do was like also make sure that when you make a selection here, that images pop up. It's like a thing you can do. But hang on, we can do something cool here with those images. So you know how when you have a pre-trained model, right? You're usually also able to just put your own task head on top of it. So like, this is like the semi-final layer of a network, and I just put a dense layer here and then like a final output layer here. Now imagine, right, that I just start by annotating some examples. 20 examples per class, let's say. And then what I'm just going to go ahead and do is I'm just going to tell the task head to go ahead and train, but I'm going to keep this the same. This is just going to stay frozen. By doing this, like this part of the algorithm is relatively lightweight. Oh, but as a side effect, I do have a new dense layer here that I can use for my embeddings. And that's kind of cool because that's going to be combining the knowledge that's in the original embedding with a bit of a push from the labels that I have made myself. And I can give you the Prodi.gy demo, and I can show you how quickly you can annotate 20 examples per class. It takes like a minute. Don't have to do that here, but here's what happens to the embedded space. Like before, the UMAP chart would look like this, but after doing that, the UMAP chart would look like this. And the data that I'm doing this on, by the way, is like a like exception has like dog breeds in them, but not cat dog per se. And I'm basically giving it cat dog labels. And after it's done, you can kind of see that it's like a long shape. You can kind of wonder, what does that shape mean? Because it seems like UMAP is capturing something global here, which it really doesn't do unless there's a good reason for it. So what might be happening is that we have dogs on one end and cats on the other end. So this is on fine-tuned data. It might take, is this one loading? Might take a while to load. Please load. Oh, yep, there we go. I'll make a selection. I'll make a selection. Oh, yeah?
Yeah, I mean, just to recap, I think while it was loading. So these are embeddings of images. And then the embeddings are not using a frozen model, but they're using a fine-tuned model, fine-tuned on the task of, at least the last layer is fine-tuned on the task of classifying dog versus cat.
Yeah. So I have my image that's being passed to this pre-trained thing. Out comes, the k-dimensional embedding. Okay. That embedding is passed to like a final, like my own dense layer, yeah. And then like an output layer, so to say. Yeah. And I'm only updating this part. But if I then afterwards say, well, what's in this dense layer then? Well, it's some combination of stuff the gradient signal picked up and some combination of what the original embeddings gave me.
The embedding space is shaped to help this task of, putting cats in one place of the embedding space and dogs in another one.
And that's something that actually seems to happen. Like if you go to, it becomes quite clear, like these are all cats and these are all dogs. And this is kind of the cool thing. Suppose now that I want to have examples where the model is just kind of unsure because maybe active learning wise, those are the interesting candidates. I just select in the middle. And I get some cat-like dogs and some dog-like cats. And my theory is that the Pomeranian has like an ear that's very similar to a cat's ear. I haven't tested this theory, but that's my theory at least. But this is super cool, right? Like if I think about like human in the loop, if we can do like this bulk labeling thing where we just steer it a little, man, this might get really articulate and expressive. This is cool. Again, not going to be perfect, right? But as a getting started way, I really want to help motivate people to actually start labeling themselves. That's also part of what I'm trying to do here. I want to get rid of this notion that labeling is boring, and I want to get a little bit more towards labeling is important. We should celebrate it more, which is also why I like working on some of these experiments. Note, if you want to get...
This would be fascinating to do with clip embeddings, where you can embed both images and text to the same space.
Embetter supports them. No, it does. So because we support sentence encoders, we also support clip. That's one of the features. Okay. I think out of the box, when you give it like a Python image object, it should already work.
Fascinating.
I haven't tried it, but the doc suggests it's fine. If you want to sort of get the full tutorial on this, again, Explosion YouTube channel. This is content I make. These are tools that I'm writing. Whenever I get like a new milestone for a tool, the company lets me make a video about it. So definitely give that a check if that sounds like something you're interested in. But yeah, these are the tools that I was working on, and we are like already kind of over time. So I hope that this was interesting to a lot of folks there. A lot of people sometimes ask me what's next with this sort of stuff. I'm definitely interested in data quality stuff some more. I'm also doing some lightweight ML stuff and some Calm developer tools. So bulk labeling for named entity recognition. How do we find substrings? That's definitely something that's in the pipeline. I'm also interested in stronger than weak supervision. There are some cool ideas in weak supervision, but I want to come up with labeling functions that are not weak. There's some fine-tuning tricks, stuff that I just showed you. I want to have that in Embetter at some point as well. I'm also working on active learning stuff, and there will be 2 new libraries that I hopefully get to work on in December. But this is like the realm that I'm trying to work in, and I hope that people also recognize I'm kind of building towards a stack. And that stack so happens to be something that integrates very, very well with the tools that we make at Explosion, in particularly their labeling tool. But I'm also doing like non-text stuff there, computer vision, data deduplication. Those are also things on my mind. If you like what you see here, lovely, happy to hear it. But don't just follow me. I have a bunch of interesting colleagues. We build a bunch of interesting tools. Like all of our internal tools, like serialization packages, are also open source out there. And if you think my demos are cool, I've seen some of the internal stuff my colleagues are working on. It's better. I just want to give a shout out to that. Another thing, like if you really like to use spaCy, we've also started like an offering for that these days. Like you can get us for consultancy. We want to prevent that we become a company of people that make the tool but don't use it. So definitely we like to use it this way because it also helps us inspire new features. So if that's interesting to people, please check that out as well. Having said that, everyone, thanks for listening. It's been a long talk. You can find me online. Coding.io is my blog. Calmcode is this other side project that I run. Feel free to ask me anything. Thanks for having me.
Thank you so much, Vincent. That was an incredible talk. Just 2 things I really wanted to ask you before. So one, you're building this stack. This stack has scaffolding, it seems, which is the scikit-learn API. Clip is automatically supported because you're building on tools that have APIs that can work together. Could you speak to, why you chose scikit-learn, and what do you think about that API? Where is it limiting? How can it be improved?
I mean, the thing with the main downside with scikit-learn is when you have 2 components after each other, like you cannot pass a gradient between them. Like they are independent at that point. So that you can look at that and say that's a bit of a weakness. Fine. The benefit is it just keeps things simple. It's Lego bricks. They click together. And it really makes you productive, so to say. Like that's the main reason I would argue that people should maybe do more scikit-learn stuff. And it's also like ubiquitous. People know how to use it. It's been around for ages. It's not like a hip new thing. It's really robust, well tested.
Amazing. That's a great lead up to the second question. Productivity. How do you have time to build all of this, to document that code meticulously, to explain it via videos and well-documented GitHub pages and 600 or so videos on Calmcode? What are your tips for how people can be sort of productive and
I mean, everyone kind of needs to figure that out for themselves, because something that makes me productive might not work for everyone. I will say like a few things that help me. I like to solve problems on paper before I start writing code. So like if I don't know how to solve something in my mind yet, why bother writing code? Like sure, you want to do exploratory data analysis, but like at least solve it on paper first. That's usually the time saver. And I take long walks in the morning with the kid in the stroller, so I have time to think about that sort of thing. I suppose another thing, I mean, if you've done something once, it's easier to do it twice. And if you've done something a third time, it also gets easier. So the main thing, I guess, that I also got good at is just, it was kind of hard to make my first package, but then, I just practiced. So my recommendation here is try to write your own packages more. Do less in a notebook. Take reusable functions and actually reuse them. Maybe that's a bit of a better advice.
Absolutely. Thank you so much, Vincent. That's been a great look at these tools. So yeah, thank you so much.